So soil is a mixture of organic matter, which we call humus, minerals, gases, liquids, and other organisms that together they support life. There are different layers of soil. Those we call them horizons. So you will see soil horizons popping up from time to time. Soil texture, when you think of texture, like from primary school, you would think of how things feel. So soil texture describes really the size of the particles that are present. So for soil, we can have sand, we can have silt, we can have clay, etc. Sand is the largest in particle size. So when you go to the beach, for example, the sand looks extremely fine, but at least you can separate it enough to actually take up one single grain. That is why we know that it's the largest, because with silt, you cannot take up a single grain because you can't find a single grain. It's too small. With clay, you cannot pick up a single grain either because it is too small. Do you understand? So that is why it is so easy for like clay to stick together, for you to mold it into something, because the particle sizes are so small. So because clay is so small, it clumps together easily. Sand, it is harder for sand to clump together. So even when you are making a sand castle or something, it is easy for the sand to fall apart. Loam is what we enjoy for planting in. Farmers would prefer to plant in loam. It has about 40% sand, 40% silt, and 20% clay. So it gives you a very good mixture of all of these particle sizes together, so it can allow for your plants to grow properly. So what I want you to understand is the relationship between soil, weathering, mass movement, and rock formation. So that is why they would all come under one question. So that is what you can expect on your number one question. No, not number one. Number one is going to be map work. Number two, that's what you can expect on number two question for your CXC exam. So there is a relationship between all of these. We saw the relationship a while ago with soil formation and weathering itself. And then with weathering, we saw the relationship between, with mass movement. We saw the relationship between mass movement and weathering, because the landslides and the soil creep, etc., is actually moving the material that has already undergone weathering. So now it's now available to be moved. And then we see the relationship as well between rock types, rock formation, and all of these combined. So you have a pretty good idea of what your question is going to look like with all of these combinations together. Do you understand what I'm saying? Let us talk about organic matter. So organic matter in the soil is called the humus. This would have been the O horizon in the soil. So this is the top section. This is the section that you and I would actually see. So it is an accumulation of decayed matter, such as plants and animals. So when we say we're doing composting, if we're putting all of our kitchen scraps together, etc., and then we put in some soil there, and then it gets wet, and eventually when you go back, it's all deteriorated. You're basically making humus, which would have been the organic matter and the top layer of your soil profile. All right. So what is the soil profile? The soil profile, it consists of the several different soil horizons, or the different layers that the soil is made up of. So these different layers, we have the O layer, which is the humus that we mentioned before, that would have been at the very top layer. So that is where we have plants that do not have very long, thick roots. Those plants, their roots would be in the O layer only. Do you notice sometimes if you probably go outside and you are supposed to weed up some plants, weed up, I don't know if your parents ask you to pull out weeds, do they? So with that, you will notice that some of the vegetation that you pull up, some of them will come up easier than others. Some of them, when you pull them up, all you see is just the brown O horizon on the root. But others, when you pull them up, you see maybe a whiter material, or you see a different color on that root because it is deeper down. It is harder for it to actually pull out, right? So that is giving you an idea of what the soil profile would involve. So we have the O horizon at the top, we said, which is the humus, which organic matter, which we just spoke about. Then we have our A horizon, which is right below that. This is our topsoil. So this is rich in organic matter as well. It is very dark, but it is also called the zone of leaching. So we can have, it has a high content of the organic matter. So when you have the O horizon at the top and you have minerals that are washing from the O horizon, they would go down to the A horizon and stop there. Most of the times they would stop there. So that is our zone of leaching. So that is also good soil for planting, right? Then we have B horizon, which is our subsoil. This is also called the zone of accumulation. So we have fine materials there, and minerals will just precipitate in that area. So we have clay, we have iron, we have carbonates, we have gypsum, things like that would have been in this particular area. So we call it the zone of accumulation because we have a wider variety of things present or accumulating in this particular area. So only very, very large tree roots would actually venture down to this B horizon. Then we would go to horizon C, where we have the weathered bedrock. So we have rock fragments of different sizes would have been found in horizon C. So this is, we would find bigger rocks down here that would just be moved from the original hard bedrock or from what we consider to be a part of our parent material. So we can look at the soil profile starting from the base where we have the original bedrock. We have different processes of weathering and erosion that is taking place, that is acting on the rocks. But the further down you go, the more, let me say, pure your rock would be. So right below the C horizon, we would have our R, which we would call our regolith. This is our hard bedrock, actual hard bedrock. Then above that now, we would have the weathered bedrock. So this is the part that has been broken up, but it is not into very, very small sizes. So the particle size, the size of the particles reduce as you go closer to the surface, right? So you would have bigger particle sizes down here, but as you go up, the particle sizes would have gotten smaller. Do you understand? So that is our soil profile. Now, we have different factors that influence the formation of soil. So what do I mean again when I say factors influencing something? What do I mean by that? So that is your cause. The causes, the things that are causing you to do what you're doing. So the factors influencing the soil formation, what are the things that are causing soil to be formed that particular way? So we have these 5 things. We have time, organisms, topography, climate, and parent material. Do you remember what the parent material is? So this is our original bedrock, or original rock, that provides us with the weathered material. Do you understand? So our parent material, this is our original bedrock, the original rock that is eroded or weathered or whatever, that would have given us the sediments that we are going to need in the making or the formation of our soil. So which rock the soil is being born as a result of, kind of like that. Okay?
Yes, yes.
All right, so that is our parent material. Then climate, I'm gonna go into climate a little more. We'll explain that a little more. Time, it really has to do with how long the process of breaking down is taking place. So the longer that we have the soil there and weathering taking place and erosion taking place, the longer we have it there, the longer we have things in it, all of these things put together with time will create the type of soil that we're going to end up with. It's like you're cooking something. So the longer you keep it in the pot, it gives you something else. All right? Then the organisms now. These would have been, what would have been influential in our organic matter creation? Not only there, not only the dead ones, but the ones that are alive as well, that actually go through and burrow through the soil, burrow through the parent material, through the rocks, etc. That makes the material now more readily available through the process of weathering. So depending on the type of organisms that are present. Also, if you have, I don't know if you've ever heard somebody say this or your parents say this, but anywhere where you have a lot of worms, it is showing you that the soil in that area is very fertile. So organisms also play that major role in determining how our soil is going to turn out, what type of soil we're going to end up with when the formation process is taking place. Do you understand that so far?
Yes, miss.
All right. And the topography now, it's really talking about like the relief of your land, what kind of slope it is on. So if we have our soil forming on a very steep slope like that, it means that on this area here, it is going to be difficult for us to keep all of the organisms and our topsoil. Why is that? Why is it difficult for our topsoil or our O horizon to stay on this area of the slope here? So the gradient of the slope will influence mass movement to take place. So is either soil creep gonna take place here so, or some landslide gonna be taken here so, but it means that our topsoil is gonna be washing away. It's gonna be moving away. So the layers that we end up with, it may mean that we have a very, very thin layer of topsoil if we're using this area as our soil profile alone, right? But if the gradient is flatter like this area, all of the material that comes off the slope here, it is now going to settle at the base. So we would have had a greater accumulation of topsoil right here, and then our other layers, we could find them underneath just the same. Do you understand those? All right, so we're gonna look at climate a little further. I wanna show you a diagram where climate is concerned for you to see how climate actually intricately influences the type of soil that we have. So let's look at the other factors first. So if you start off with a big rock, which is our parent material, the big boulder, leave it there for a very long time, it will break down because of weathering. So this we know already. It's exactly what we just discussed. Both mechanical and chemical weathering will transform that boulder into different size particles, different size sediments. So I would end up with sand size particles, silt size particles, and clay size particles. Now, when I have those, my climate would determine the amount of rainfall that I get, and it will also, the amount of rainfall also determines the amount of water that will be passing through my soil. And remember that water is very, very influential when we are talking about mass movement, as well as the fact that water, through the process of chemical weathering, can also assist in the breaking down of rocks as well. You understand? So the more water that we have, the more rainfall that we have in the particular area, it will determine how far down we have materials being eroded, what our soil profile actually looks like. So that is very big in determining what our soil profile looks like or how our soil is actually formed. Then the organisms now. Organisms assist in the breaking down of soil. Organisms are also linked to climate, because if you are in a very, very cold climate, the worms and other little organisms that would have been present in the soil in warmer areas, they would not be able to live in these frozen soils. So if they're unable to live in these frozen soils, then what does it suggest about your ability to plant and have nutrients in these frozen soils? Would there be a lot of nutrients present?
Not at all.
Nope, not at all. You are correct, right? So organisms are also linked with climate. So the organisms, they assist in the breaking down of the soil, and the topography, like we explained earlier, it determines how much of the soil actually washes down the slope, because we're talking about the gradient where the topography is concerned. Any questions? So let us look now at soil formation and climate. So this is, it didn't ask for this specifically this way, where the syllabus is concerned, but most of soil in your syllabus is linked to climate. So it is in the section of your syllabus under weather and climate. So it's weather, climate, vegetation, and soils, somewhere there. So that is where it is really linked, because climate, very, very important in formation of soil. So let me explain the diagram first. So different climates produce different types of soils. We will have different soil formations taking place, right? So up here, we're seeing precipitation. We're seeing rainfall levels. You see the amount of rainfall per year in each of the different climatic areas, climatic zones. So this is our tropical area, and we're seeing that we get 100 to 200 centimeters of rainfall per year. We understand that section? So we are looking at our different climatic zones. So we have the tropics here, we have the desert here, temperate regions, and the Arctic here. At the top, we're seeing precipitation. So it is showing us that in the tropics, we have 100 to 200 centimeters of rainfall per year. Understand that? So the quantity of rainfall, the amount of rainfall that we have, also determines the type and the quantity of vegetation that we have. So you notice that we have a whole heap of different types of plants in the tropical area. Do you notice that? So we have plants at all different layers in the tropical area, and we have a wider variety of plants. Also, we can see temperature at the bottom section here. So temperature, that's the purple line, this one here. Temperature is high and reduces as you go across the different climatic zones. So in the tropics, the temperature is high. So it's a lot of information all in one. So I want to ensure that you understand the diagram first of all. So in the tropics, we have high temperatures, we have high rainfall levels. So because we now have a warm climate all year round, so the temperature remaining high throughout the time, and we have lots of rainfall throughout the year as well, that gives us a lot of different types of vegetation growing in the tropical areas. Now look at the soil profile for the tropical areas. So the brown section here is showing the soil. Below the brown section, the dark brown section, this is our soil. This area here is showing the parent material. And what did I say the parent material is again? This is my original rock. So all down here says my original rock. So look at this now. If you were to compare them, when you look at the tropics would have the deepest soil. Can you see that?
Yes, miss.
Aha. So the climate influences the type of soil that we get because of the quantity of rainfall and because of the levels of temperature. So it influences the type of soil that we get, because with rainfall like that, because the area is mostly wet or damp, and then the temperature is warm, you will have lots of different species just crawling through the soil. So they are putting air in it, they are leaving minerals in it, there are different animals that are dying, and then the worms decompose them. So all of that adds to the organic matter in the soil. Because we have so many plants as well, lots of leaves would fall off, and then all of those would decompose, and then you have a very, very nice top layer with very, very fertile soil that can grow almost anything. Do you understand now the variation? So then we go over to the desert areas. Where we are in the desert areas, we can see that there is up to 25 centimeters of rainfall per year. That is a very, very small amount, right? So look at the type of vegetation that is present. So the temperature is relatively high, but then there's a small amount of rainfall. So it's almost like drought. So you would end up with a situation where you can only have just a small amount of different plants that can live or survive in that particular area, right? So as a result of that, the soil is just a very, very thin layer of soil that is present. Then over to the temperate regions, you do have a large amount of rainfall here. So we have 50 to 200 centimeters per year. So it fluctuates, it fluctuates from time to time. And then you have the temperature. It would have gotten a little lower, but you do have vegetation that is present. But because the temperature would have gotten so low, which is around 0 to 10 degrees, so it's kind of cold from time to time, you do not have so many different organisms present. Also, because of the temperature that is there, you do not have a wide variety of plants either. So if you look at the type of plants that is present, you can see that it's basically 1 or 2 types that is present in that particular area. So it doesn't look like a nice fancy rainforest where you will have lots of small animals running around that will assist you in your soil production. So you do have enough to give you the soil production, but it would not be as deep as we would have in the tropical areas like here. So their soil production would be right here, and most of it would have been parent material. Are you understanding this so far? The final section now, we have the Arctic. We know that the Arctic is cold. You can see the temperature in that particular area. And as the temperature reduces, so does the vegetation in that particular area as well. So you can see that in extreme temperatures, so in the desert areas, look at the vegetation, and in the cold areas, look at the vegetation. Vegetation is very, very low, right? So look at the soil depth as well in both areas. You have a thin layer of soil in the very warm areas and a thin layer of soil in the very cold areas, and limited vegetation as well. So climate itself is very influential in the production of soil, and climate itself will determine the depth of the soil that is there. Climate affects all of the other things, all of the other factors that would have been influencing soil formation. Any questions? So our question now, explain the relationship between soil formation and weathering.